Hi, in this video I want to introduce the last um, main feature that we can find on geological maps at GCSE, and these are faults. Now faults have been covered previously in the course, so really we just need to think about how these are represented on a geological map. Now like this block diagram shows, a fault is where rock under stress gets broken and moves. So we see a displacement. Rocks moved from their original location. The block on the left there has moved up, what we call the upthrow block. The block on the right has moved down, what we call the downthrow block. Now there are four different types of fault because of different types of stress that create them. Normal faults are created by a tension stress, where the rocks get pulled apart. What we see as a result is the rocks get extended, they get pulled apart. We see the downthrow block there being the hanging wall of the fault. The upthrown block is the footwall of the fault. You might want to go back to your work on faults to remind yourself what these terms mean. Here's a photograph to show a normal fault in a cliff. If we look, we've got a red bed there at the top that has been downthrown by what, a couple of meters, 2-3 meters there perhaps, on the hanging wall side of the fault, making it a normal fault. A reverse fault is created by crustal compression. So here the rocks get shorter, get pushed together. The hanging wall here has actually been upthrown. The footwall has been downthrown. This photograph shows an example, a fairly small scale. You can see the hammer there for scale. See how that white bed has been displaced, maybe only by about 10 centimeters. But you can see how the hanging wall there has moved up, making it a reverse fault. Now we can also see thrust faults. Thrust faults are a type of reverse fault. So again, the hanging wall is upthrown, the footwall is downthrown, but in this case, the angle of the fault plane, the inclination of that fault plane, is quite gentle. This really can thicken up the crust. This is the type of fault that's quite common in convergent plate margins. Finally, then we have strike-slip faults. Strike-slip faults see a horizontal displacement. So we see rocks move from side to side, not up and down. So any vertical structures will get displaced, and we'll see the same sequence of beds either side of the fault. The San Andreas fault, a conservative plate margin, is a good example of this. Now, that's a very quick overview of faulting. For more detail, you need to go back to the previous work we've done on this. But let's have a look at map K. Map K shows us a fault. We can tell there's been a fault because there's a displacement of beds. The cross-section as well shows us what that displacement is. We can see, for example, that there's been a vertical displacement of these beds. Okay, have a go at question 11. Work through those questions. Go back to check out the work we've done or the videos on faulting and see what you can come up with.